the one thing that is kind of important. So there's going to be a lot of moving parts to this. Okay, because we're going to try to get our rig and our animations out of Maya and into Unreal.
Not Unreal.
Yeah. And then we're going to go a step further, and we're going to try to create an animation blueprint so that you can actually run around as your character. Okay, so don't worry, it's not that bad because Unreal ships with this template that is pretty functional. So we've already got all this functionality, running and jumping for a third-person character. So we don't need to reinvent the wheel. We can utilize that, but I want to apply our animations to it. Okay, so the first, no, go ahead.
Were we supposed to do a running animation?
No, and I'll show you why. Once Unreal 5.4 is done downloading, one of the really useful things they added in 5.4 is a really smart animation retargeter. So you can take your rig and you can apply that literal animation to your rig. So it's good to make a running animation if you want to, like if you want like more unique character or whatever, but if you just need like a placeholder, you can totally just take the one that comes with Unreal. And in fact, my game, I haven't made an actual running animation yet. It's still, well, I'm using the lower half of the default one, and then I just have like upper body additives. So
I like how there's like three to four different files of just Captain McSpace.
oh, bro, yeah, it's a mess. It's a mess. All different branches, all different random things from freelance projects, all different things that I've downloaded just to toy around with, and yeah, lots of Captain McSpace with it. All right, so 5.4 is downloading, that's fine. So what I want to show you is in in third person, we've got a lot of stuff. So this is the third person character blueprint. Has anybody worked with Blueprint before? Yeah, some hands. Okay, cool. Well, this is going to be a really good kind of like slow intro to blueprinting. And I should be teaching blueprints next semester, so hopefully you're all in that class. And this will give you
They have a different course code, so I'm going to ask Alan if I can retake it.
Oh, nice. That'd be awesome. It's going to be something about programming with Blueprint or something like that.
Yeah, I also.
I forget what the course code is offhand.
If
Just whatever any of my classes are, you should just take them because they're great.
Alexis, when you find that out, can you let me know? I also I need classes.
The reason a lot of people, I think everyone that took the game scripting the first time, it doesn't come up on the registrar side, so Alan has to like submit a thing to the dean to be like, hey, they took it. But I'm like, hey, can I just retake it? Because the school says I didn't take it.
Oh, yeah. Nice. Cool. Okay, so this is Blueprint, and Blueprint is awesome. It's a programming language where instead of typing confusing sounding words into a big text file, you just connect all these Lego bricks together. So, add movement input, boom.
Yeah, but what those Lego bricks do is a big text document of.
Yes, these Lego bricks make a big text document of code.
What? Art 3130 is the name of the scripting course. Game design scripting is the full title.
But that's his class?
Yes.
That's the blueprint class you're talking about?
Yes.
You scared me for a second because I had no room to do electives, and I was like, I really need a blueprinting class. And I literally yesterday, I was like, I really hope game scripting is the blueprint class.
31.
Yes, it is.
You said
Okay.
Yeah.
31,
You scared me
30.
because you said every name, and I was like,
Oh, Blueprint is scripting.
That's
No,
what I assumed.
this is just the academic calendar.
Alright, be chilling. I'll take you that
I would
next
ask
semester.
Nice. Cool. All right, so this will be a good little intro. Okay, so this is Blueprint, but what we want to specifically talk about are animation blueprints. Okay? Animation blueprints are a lot like blueprints, but a little bit different.
Janky.
They're awesome. So if by janky you mean awesome, then correct. Okay. Okay, animation blueprints have an event graph and an ANIM graph. Okay? If all this is really confusing, don't worry about it. It's going to be really confusing, but that's fine. It'll all start to make sense over time. Okay, so if you look, basically the way this works, the event graph is where you use data to set variables in your ANIM blueprint that you can use to drive other things. Your ANIM graph is where you set up the logic for blending between different states using those variables. Does that make sense so far? Okay, let me show you. So in main states, let's just in fact, let's just look at this one, locomotion. Okay, so we got a state machine, locomotion. This is a good simple one. We've got two states, idle, and then we've got a state called walk/run. Okay, how do I, let me explain one more thing first. Okay, in walk/run, we have something called a blend space. Okay, I know this is a lot of stuff, but like, trust me, it'll all just kind of fit together. And you can open up this file and you can just kind of like, you know, poke through it. So it'll all start to make sense. So this is a blend space. Okay. What's a blend space? A blend space is two animations being blended together. Okay. So this one is, you see these three dots? These are different animation clips. Okay. So this one is, and it's got a value assigned. So this one is 0, this one is 230, this one is 500, okay? So what that means is as you change the value, you see, so I'm changing the preview value, so now it's 94, now it's 100, see as I move it up, you see how the animation is changing? And then when I go past here closer to 500, you see how it transitions into a run? That's pretty cool, isn't it? Okay, so this is only two animations though. And so let me open up. Oh. Okay, I was gonna do something. Basically, each one of these is an animation clip. Okay, so this one is called walk forward. This one. So this is the animation. Then this one is called, what's it called? It's called run forward. Run forward, okay? And it looks like this. So when I go in here and I put it like in this like half jog, what am I looking at? What animation sample? Let me ask you this, when I've got it here, what am I seeing? What animation sample am I seeing? I'm seeing the walk forward animation, right? And when I put it here, what am I seeing?
Run.
I'm seeing the run forward animation. So when I put it here, what am I seeing?
Low.
Yeah. I'm seeing a blend of both animations, which is kind of a weird thing to wrap your head around because it's movement, right? But it's literally blending, it's literally half of the walk animation overlaid with half of the run animation. Just like you would, you know, change the opacity of a layer in Photoshop, we're changing the opacity of an animation in our animation graph. Okay? And what are we using to drive this blend? Any guesses? Any guesses? Let me ask it another way. So we've got this 0 to 500. Okay, so what is that? Good guess. Speed. Yeah, exactly. So, well, technically it's just a value. It could be anything. We're just in a blend space. So the value, it's just 0 to 500. It could be anything. But if I look here, so this is my blend space, BS, walk, run. And look at this, it's got a variable called speed. And I'm connecting this box that says ground speed to it. So what's this? It's our speed, right? Okay. So any guesses on how this goes in, like where this comes from, this ground speed variable? Yeah, what were you gonna say? Yes, yes. It comes from the speed at which the character is moving. So when he's standing still, it doesn't do anything. And then when he starts moving slowly, so like if you've got an Xbox controller and you like push forward on the joystick just a little bit, and he's creeping forward, he'll move a little bit. And if you push all the way forward and he's sprinting, then he'll run. Okay? And so we do that, so we populate this ground speed variable in the event graph. Okay, so we've just come back around to the beginning. Remember, we started talking about the event graph, and I was talking about the ANIM graph. They work together. So in the event graph, one of the important things that we do is we have a reference to the movement component, and we get this vector length of velocity, and we set that to ground speed. Okay? So does that make sense? Like we're taking the velocity that the character is moving at, and we're caching it as a variable, and we're using that variable to drive our blend space to switch between the walking and the running animation. Does that make sense? Yeah, I know it's a lot. Especially since, you know, if you're new to like the concept of blueprint in general, this is like a big pile of info, but don't worry, we're gonna get there. Okay, that's blend spaces. I wanted to cover that first. All right, so there's another, so we have two states here. We're gonna talk about these two states, and I think this will help a lot. So that one was kind of complicated. That was a blend space. The idle state is much simpler. Look at that. This is a pretty simple graph, right? Can anybody guess what's happening here?
Telling the character to stay still.
Yeah, we're just playing an idle animation. We've just gotten a sequence. It's just an idle animation. And so all we do is we just connect it to our animation pose, and this is our idle state. So that's our idle state. Our walk run is a blend space. So we have two states, and then we blend between them using these transition lines, okay? And so if you hover this, it'll tell you the rules that cause the transition to trigger. And if you double click, it opens up the logic. And the logic here is pretty simple. What have we got? Can anybody guess what this is called?
I would love to. Oh, yeah, it's a Boolean.
Yeah.
See, I'd love to read the text.
Not to be confused with Booleans in 3D modeling. This is Booleans in computer programming. And so Boolean just means yes or no, right? So we've got this variable called should move, and it just feeds directly into this can enter transition. Can anybody guess on the return? So that's idle to walk run should move. If true, moves to walk run. Can anybody guess how we would go back from walk run to idle? Just logically.
Just do false.
Yes. If should move is false, then can. Then yeah, this is like Booleans. If should move is true and not, which means false, then can enter transition will be true. Right? Because in this case, can enter transition goes backwards. Okay?
Okay.
Yeah.
God, I hate Booleans. They're so easy, but also like, what the fuck?
Yeah. Think about it this way. The way I just described it is the most accurate, but maybe not the most intuitive. So should move. Let me just get rid of this. Let's recreate this. Can enter transition. Right? So it's walk run. It's this one. So when can enter transition is true, we will move to idle. If can enter transition is false, we will move to walk run. All right? So let's recreate this graph. What do I need to put in here?
The should move.
Good. So should move. Is this right? Should move.
No.
True. Okay, what's going to happen?
It's just gonna.
You're never gonna be able to stop running, even if you stop.
Correct. Because should move is true.
Or you'll
So
stop.
it's going to go straight back. Actually, I'm not even sure what would happen if I ran this right now, but it wouldn't do what we want.
Honestly, I'll probably just play the running
It'll
animation.
stop moving, but it'll play the running
Yeah.
animation while you're idle.
Basically, should move will be true, and so it'll jump back to idle when it shouldn't. Yeah, you'll always be playing your idle.
Oh.
Yeah.
I thought you'd always be playing when you're running.
No, you're always going to play your idle because when should move is true. No, you might be right. When should move is true, it'll play walk run. But if should move is true, it'll also, it might just be random actually, because either one of these are both going to be true at the same
Is
time.
it just gonna be infinitely cycling through?
Well, let's find out. Why are we talking about it? Okay, so I'm just idle. Interesting. But what I think is probably happening, I think it kind of could be either, right? Because we're getting philosophical. We want this to be opposite, so we need a not Boolean, and you can think of a not Boolean as just being like a reverse. Just it'll make yes no, it'll make no yes.
So whenever it's not false.
If should move is true, the not will make it false. If should move is false, the not will make it true.
Okay.
So in this
how
case,
do we
should
make
move.
Why is should move true? Is it just called? Is that the base?
Should move? That's a good question. Yes. What drives should move? Well, we've got to go back to our event graph. Where did we set that? Yeah. So down here, this is what sets the value of should move. So see, we have this set node.
Oh, it's if the player movement speed is of a certain.
If our movement current acceleration, so basically, if ground speed is greater than 3, and what is this even? Okay, and current acceleration is not equal to 0, then should move is true. This is a little confusing. We don't need this. Let's delete that. Let's just make this simple. So if ground speed is greater than 3, then we should move.
Why was all that excess stuff?
It's there for some edge cases that don't crop up very often. I'm not really sure, and it actually causes some problems in other situations. I'm not really sure. I have to kind of look into it, but I find I like that this is better. It's just simpler, and I haven't had any problems with it. So ground speed greater than 3 should move is true. So that triggers our transition, and then we can move. So yeah, now it's working the way we want. Okay. Good news about all this is you don't really have to understand any of it. Because for our intents and purposes, we really just want to replace this mesh with ours and replace the animations with ours.